Hi, welcome back. Today we are going to learn treatment of sewage, which is classified as step 1, primary treatment, step 2, secondary treatment, step 3, tertiary treatment or disinfection. Again, treatment of sewage classified as primary treatment, second, secondary treatment, and third, tertiary treatment. Remember. Now, first look at to the step 1, that is primary treatment. In primary treatment, we are first removing the larger solid. Second, broken up more complex compounds and converts into simpler compounds by decomposition. Right? What we are looking at? Removing the larger solids, and second, broken up more complex compounds and converts into simpler compounds by decomposition. In primary treatment includes first, screening, second, grid chamber, third, detritus tank, fourth, skimming tanks, and fifth, sedimentation tank with or without use of chemicals. In secondary treatment, in this process, sewage treated exhaustively, biologically unique process, and it is completely purified by activated sludge process or by filtration. That means in secondary treatment, we are concentrating to activated sludge process or by filtration process. Step 3, tertiary treatment or disinfection. This is an auxiliary or additional treatment, and it may be adopted either in combination with primary and secondary treatment. Right? Disinfection carried out generally by chlorination, which remain in effluent of sewage. Next, theory and design of screen chamber. The purpose of screen chamber is, the main purpose of screening is to remove large size floating matter. So, such material not removed, they will choke up the small pipes and or affect seriously on sewage pumps. That is, main purpose, avoid possible damage to all equipments and pumps from floating matter of sewage. Location of screen chamber. The screen should be located before the grid chamber or after. Screens are usually inclined in position at 30 degree to 60 degree with the direction of the flow. The screens are sometimes in the body of grid chambers. Please remember. Types of screen. First, remember the classification of screen are as follows. First classification according to the size of openings. Second, classification according to the condition of screens, right? First, classification according to the size of openings. The screens are classified as coarse screen, second, medium screen, third, fine screen. What are they? Coarse screen, medium screen and fine screen. Thus, the spacing between the bars determine the type of screen. Remember, we are looking first coarse screen. See, coarse screens are known as racks. Spacing between the screens about 40 mm or more. Coarse screens reduces organic loading of sewage to some extent. Medium screens, the spacing between the bars about 6 mm to 40 mm. See, in coarse screen we are providing 40 mm. Now in medium screens it is in between 6 mm to 40 mm. Now third, fine screen. The spacing between the bars about 1.5 mm to 6 mm. Fine screens made by brass or bronze, etc. The metal should be corrosion resistant or rust resistant. Fine screen made up by disc or drum type and operated continuously by the electric motors. The rectangular coarse medium screen are widely used in sewage treatment plant. They are made of steel bar which are fixed parallel to one another at desired spacing rectangular steel frame. They are also known as the screen bars and are set in masonry or RCC chamber known as the screen chamber, right? Second, classification according to the condition of screens. Let us see. According to the classification, screens are classified as first, fixed screens, second, movable screens, and third, moving screens. Once again, according to this classification, screens are classified as fixed screens, second, movable screens, and third, moving screens. Please keep in your mind. First, fixed screen. Figure shows fixed screen are as follows. The perforated platforms provided to receive the material collected from screen bars. That means perforated platforms, what they are doing? They are collecting the material which are coming from the screen bars. Please remember. Here is the diagram. Upper side diagram which are shows here section part is, and below there is a provided plan. This is your screen bars, clearly shown screen bars. Here also the screen bars shows here. At what degree it is provided? 30 degree to 75 degree. Okay. The water is coming from inlet chamber. See, this is part A, coming from A, water is get inside. That is sewage water, right? And water is going flow through these screens and move to the outlet, that is direction of B. And this is your perforated platforms which collects your material here. That means you understand that through this plan and section, water is coming from, sewage water is coming from the direction A to the direction B, and below, in between that, there is a screens, that is bar screen are provided, and after that material is collected or received from perforated platforms here, बरोबर? And the sewage water, it is moved to the direction to the B, that is outlet. It is very simple diagram. Right? Now we are moving from theory and design of screen chamber, that is second part, that is movable screens. The movable screens are stationary during their operating period, but they can be lifted bodily and removed from their position. The moving screens, that is third part, are moving during their operating period and they are automatically cleaned while they are in motion, right? Cleaning devices. In screening, cleaning devices are provided. First, that is hand rakes, and second, mechanical rakes. Barobar? Next, in this theory and design of screen chamber, cleaning devices, what are they? Hand rakes and mechanical rakes are used for cleaning of screens. The rakes are like toothed bar, right? In hand-operated rakes, laborers clean the openings of screens twice or thrice of the day. The teeth of rake so designed in such a way that they fit in between the spacing of screen bars. In this theory and design of screen chamber, an operator puts the rakes in position and drag the material contained screen bar dumps on the floor top level. At fixed intervals, the cleaning of screens is carried out for mechanically operated rakes. The control of working of rakes usually provided with the time clocks or floating devices. If screens are working for cleaning continuously and automatically, they clogging problems with reduced and efficiency is increased. That means you understand that now after cleaning we are providing at the screen chambers, we are solving or resolving the problems, that is clogging problems, and improving our efficiency of working of screens, and next steps too, which are provided in the sewage treatment plant. However, such an arrangement will require more power and may cause wear and tear mechanism. The cleaning of screen can also be achieved with the help of brushes, scrapers, jets of air, steam or water. What are they? The cleaning of screen can also be achieved with the help of brushes, scrapers, jets of air, steam or water. The design factors of screens requires total area of screens can be found out by first assuming suitable velocity and determining the depth of submergence of the screen at the time of this velocity. Following factors of design are to be considered. First, the velocity of flow should be kept reasonably constant and it may be taken as about 1 meter per second at an average flow of sewage. Second, the slope of screen should be between 30 degree to 75 degree. For temporary dewatering, a perforated platform should be provided because the sewage contains 90% to 95% of water. In detention period should be assumed as 0 here. In screening, detention period should be assumed as 0. Remember, maximum depth of screen should be about 1 meter. Next, quantity of screening depends on first, type of screen, and second, the size of sewerage system. The large sewerage system will give small quantity of screenings per head of population due to the fact that the larger solids are broken down during their long journey. The screens having spacing between the bars as about 20 mm, the quantity of screenings per 1000 head of populations may be assumed as about 0.015 meter cube, that is 0.015 meter cube. The density of screenings is about 800 kg per meter cube. Moisture content of screenings varies from 85% to 90%. Screenings contain about 85% of dry matter which is volatile. Methods adopted for disposal of screenings are first, burial, second, disintegration, third, incineration. Fourth, fertilizer. And we are moving to first burial. In this first method, screenings are buried into the ground. It is adopted for small works, but result obtained by this method is not always satisfactory. Please remember, screenings buried along with quick lime. Screenings buried along with quick lime. The screenings buried sufficiently deep to obtain complete decomposition and to avoid bad odors. Ordinarily, a cover of about 300 mm to 500 mm depth of porous earth should be provided on the top of screenings. Second, disintegration. In this method, the screenings are first diluted with water, the dilution factor being kept as about 60 to 100. Diluted screenings are then passed through disintegrators which break up the screenings into small pieces. In this disintegrator method, the flow from disintegrators is then diverted and it is allowed to join the flow of sewage on the upstream of screens. It is sometimes argued that by sending the flow back on the upstream side of the screens, the load of sewage treatment works is increased. This argument is not correct for the following reasons. First, quantity of screenings as compared to the quantity of materials passing through the screens is very small. Second, quantity of screenings forms a very insignificant part of the total organic load on the treatment works. The quantity of screenings forms a very insignificant part of the total organic load on the treatment works. Third, this method avoids the unpleasant duty of handling the screenings. Third method, incineration. This method proves to be most effective in large work. The screenings are first dewatered either by pressing or by centrifuging. In pressing method, the screenings are stored in the cylinder and then piston is worked to press the screenings. In centrifuging method, the screenings placed in the cylinder and then the cylinder is rotated. The screenings after dewatering are then burned in a coal or gas or oil furnaces at high temperatures. Fourth type, fertilizer. The screenings contain good fertilizing value and with special precautions they may be used as fertilizer. It is not advisable to use the screenings for crops which are consumed or eaten raw. Let us take example for design a screen chamber. For designing a bar screen chamber, 50 mld is a quantity of the sewage which is given. Solution. Step 1. Assume manual cleaning. Keep bars 45 degree width horizontal. Second. Assume rectangular bars of size 10 mm by 50 mm with 10 mm dimension facing the floor. Assume clear spacing is equal to 40 mm between the bars. Step 3. Assume velocity through the screen capital V is equal to 0.8 meter per second at peak flow. Therefore, step 4. Capital Q is equal to 50 mld millions liter per day is equal to capital Q is equal to 50 into 10 raised to 6 divided by 24 by 60 by 60. That is, we are converting into hours, minute and second and into thousand. That means divided by 1000 to the 50 into 10 raised to 6. That means we are converting that into meter cube, right? Step 5. Capital Q is equal to 50 mld is converted into 0.578 meter cube per second. That means you clearly understand that step 4 and step 5, which is converting into the meter cube per second. Step 6. In this step 6, net area of screen we have to calculate. Therefore, capital Q is equal to area multiplied by velocity, that is A into V. We already got our value of Q, that is 0.578 is equal to, we have to calculate the area, that is A is unknown, and multiply by 0.8, that is velocity, that is we already have. Therefore, area is equal to Q by V, that is Q is equal to what? 0.578. Therefore, area is equal to 0.578 divided by 0.8. We got the area now in our calculator. What is the value? Area is equal to 0.7225 meter square. Area is equal to how much? 0.7225 meter square. You got this value in your calculator, right? Step 7. Gross area of the screen. Therefore, capital A is equal to, we already calculated the value, that is net area 0.7225, which is multiplied by H by B, that is H is your 50 and 40 is your spacing in between the bars, that is 40. Therefore, 0.7225 50 divided by 40 is equal to 0.903 meters square. That means you clearly understand that the net area is 0.72 and gross area is 0.9, that is increased, right? Step 8. Therefore, We already got the value of gross area of the screen, that is 0.903 meters square. After that, put the clear meaning, that is 40 mm opening net area is equal to 0.7225 meters square, and therefore 50 mm gross area is 0.7225 50 by 40, which is clear meaning of that particular step, that is step 7. That's why I put it this step 8 to understand the step 7. Step 9, gross area of screen, right? Before going for gross area of screen, first we already assumed that our screen is inclined at 45 degree with horizontal. Therefore, gross area of screen A is equal to 0.903, right, divided by sine 45 degree, which is inclined in position screen. Therefore, total gross area of screen capital A is equal to 1.277 meters square in your calculator. This is the value which gives a correct idea about how much area you required for gross area as a gross area for the screen. The velocity of flow above the screen, right? That is step number 10. Small v is equal to, you know your velocity, that is 0.8 multiply by 40 by 50, that is inverse. Last time you do the step h by b. Now it is b by h, that is 40 divided by 50. Therefore, small v is equal to 0.8 multiplied by 40 divided by 50, which gives the answer, that is velocity of flow above the screen is equal to 0.64 meter per second. Step 11, that is head loss through the screen. Now you have the two values of velocities. Capital V is equal to 0.8 meter per second and small v is equal to 0.64 meter per second. Therefore, we have the formula HL is equal to, that is head loss is equal to 0.0729 multiplied by v square minus v square, that is capital V square minus small v square in bracket. Right below, that is 0.0729 multiplied by, we have the capital V, that is value the 0.8 square, and small v is the value is equal to 0.64 meter per second square. Then in your calculator we have to first calculate 0.8 square minus 0.64 square, and after that we multiply by 0.0729 and get the value of HL is equal to 0.0167 meter. Say 0.017 meter. Now we are converting in meter into the centimeter. That is very simple. 1 meter is equal to 100 centimeter. That is, you know that. Therefore, HL is equal to 0.017 multiplied by 100 is equal to 1.7 centimeter. Step 12, this will be the head loss when the screen is clean. Now, we are concentrating into if screen is half clogged. Okay. At that time, we consider that capital V is equal to 2 multiplied by 0.8. Therefore, velocity will be 1.6 meter per second. When the screen is half clocked, therefore capital V is equal to 1.6 meter per second and small v is equal to 0.64 meter per second. Both the value of velocity capital V and small v put it in the same formula, that is HL is equal to 0.0729 multiplied by in bracket capital V square minus small v square bracket complete. Therefore is equal to 0.0729 under bracket. We have right now we have the capital V value is 1.6. So put it into that bracket. Capital V is equal to 1.6 meter per second square. Right? What value is capital V is what? 1.6 bracket square minus 0.64, that is 0.64 square. Then in your calculator first we have to calculate 1.6 square minus 0.64 square and then multiply by 0.0729 and you got the value is for HL, that is head loss when screen is half clock, that is 0.156 meter. Therefore again we have to convert the value of meter into the centimeter. Therefore HL is equal to 0.156 multiplied by 100. Then you got the value, that is 15.6 centimeter.
These solid materials can be broken down into two generic categories, screenings and grit. Screenings will include materials such as rags, small plastic items, and personal hygiene products. Screenings can include both organic and inorganic materials. Grit, on the other hand, is made up of sand and similar materials, and is generally inorganic. In either case, screenings or grit will cause serious problems with downstream treatment units, resulting in such problems as clogged pumps, clogged pipes, jam clarifier units, accelerated wear on process equipment, and interference with biological treatment processes. The removal and treatment of screenings and grit is essential for proper operation of the treatment plant, and also meeting the standards of the facility NPDES permit. Removal of screenings and grit occurs at the treatment plant headworks in the preliminary treatment stage. Let's take a closer look at screenings. They are usually removed from the wastewater completely, or while in the wastewater, shredded into small pieces that generally interfere with downstream treatment units. Removal of the screenings is usually accomplished through the use of a bar screen or a trash rack, while shredding the screenings is accomplished with a comminutor, macerator, or similar device. Some treatment facilities may have both a bar screen and comminutor operating in series, while others may have one or the other. Now let's take a closer look at the equipment used in the screening process. A trash rack is used for removing large debris such as bottles, cans, originally a set of parallel bars placed at an angle or vertical in a channel. The bars are usually spaced 3 to 4 inches apart, maybe either manually or mechanically cleaned. Regular removal of debris from the trash rack is necessary to prevent soil problems with rodents and odors. The bar screen operates in a similar fashion to the trash rack. The main difference is the spacing of the bars. The spacing of the bars on a bar screen is generally 2 inches or less and may be either manually or mechanically cleaned. In either case, regular cleaning of the bar screen is necessary to prevent excessive head loss that results in wastewater backing up before the bar screen. If the wastewater backs up before the bar screen, the velocity of the wastewater will slow, allowing solids to settle out and could result in septic conditions, or it could cause the bypassing of raw, untreated wastewater into the stream. There are many types of mechanically cleaned bar screens. Some screens work with a continuous chain and rake mechanism that loop around and clean the bar screen. Some bar screens do not have any submerged bearings or chains and are cleaned with a long arm or a raking mechanism. Another type of mechanically cleaned bar screen is called the arc screen. This screen gets its name by the arc shape of the screen. Most mechanical screens are triggered by some type of automatic device that signals the unit when head loss through the screen increases. Automatic devices could include float switches, bubbler controls, and ultrasonic devices. And some mechanical clean screens are controlled by a timer. The debris removed from the bar screen needs to be dealt with in accordance with the appropriate solid waste regulations. Screens should not be allowed to accumulate at the wastewater treatment facility, as they will cause problems. In addition to, or in place of a bar screen, a facility may have a comminutor. A comminutor is a device that is designed to shred the materials in the wastewater in order to then pass through a 1/4 inch stream. The comminutor generally has a set of both rotating and stationary cutting heads. Some comminutors oscillate back and forth, while others turn in a complete circle. In either case, it is necessary to keep the comminutor equipped with sharp cutter heads to ensure proper operation. When cutter heads become dull, the comminutor tends to tear the material instead of shearing as it is designed to do. Generally, it is not effective to sharpen comminutor teeth, as sharpening only compounds the problem. Comminutor cutting heads and teeth take quite a pounding and need to be replaced periodically. In most cases, the majority of wear of the comminutor occurs on the lower half of the unit. On some comminutors, it is possible to swap the bottom and the top teeth in order to even out the wear of the teeth. There are many types of comminutors and similar devices on the market today. As with all mechanical equipment, extreme care should be used when working on or near this piece of equipment, as it is capable of chewing off body parts with ease. Another